We want to sketch each of the negative angles in degrees in standard position and then convert each angle to radians. When an angle is in standard position, the initial side is along the positive x-axis. When the angle is positive, the rotation is counterclockwise. When the angle is negative, the rotation is clockwise. I've listed several common negative angles below, which we should be familiar with. All of them are based upon the fact that negative 360 degrees equals one full rotation clockwise from the positive x-axis. Let's begin by sketching a negative 50 degrees in standard position. The initial side is along the positive x-axis. Because the angle is negative 50 degrees and negative 45 degrees is 1/8 of a rotation clockwise, we rotate clockwise 5 degrees more than 1/8 of a rotation. We indicate the rotation using an arrow, like this, and it stops at the terminal side. The terminal side of negative 50 degrees would be this right here. For all these angles, we're not using a protractor, we're estimating the best that we can. And now to convert from degrees to radians, because 180 degrees equals pi radians, we multiply the angle in degrees by pi divided by 180 degrees. Let's first write negative 50 degrees as a fraction with the denominator of 1, and then we multiply by pi divided by 180 degrees. The units of degrees simplify out. The greatest common factor between negative 50 and 180 is 10. Negative 50 divided by 10 is negative 5. 180 divided by 10 is 18. Negative 50 degrees is equal to negative 5 pi divided by 18 radians. Sometimes you will see an RAD for radians, but it's more common to leave the units off. Whenever we have an angle that doesn't give units, we assume the units are radians. Next, we have negative 130 degrees. The initial side is along the positive x-axis. If we rotate 1/4 of a rotation clockwise, we would be at negative 90 degrees. This indicates we need to rotate another 40 degrees clockwise to reach the terminal side of negative 130 degrees. The terminal side would be approximately here. And now let's convert negative 130 degrees to radians. Again, the units of degrees simplify out. The greatest common factor between negative 130 and 180 is 10. Negative 130 divided by 10 is negative 13. 180 divided by 10 is 18. Negative 130 degrees equals negative 13 pi divided by 18 radians. Next, we have negative 265 degrees. Because negative 90 degrees times 3 is negative 270 degrees, we rotate 5 degrees less than 3/4 of a rotation clockwise for negative 265 degrees. The initial side is along the positive x-axis, and then rotating clockwise we have negative 90, negative 180, and then just short of negative 270 degrees, the terminal side would be approximately here. Again, just short of 3/4 of a rotation clockwise. And now let's convert to radians. The units of degrees simplify out. The greatest common factor between negative 265 and 180 is 5. 180 divided by 5 is 36. Negative 265 divided by 5 is negative 53, which indicates negative 265 degrees is equal to negative 53 pi divided by 36 radians. And for the last angle, we have negative 312 degrees. The initial side is along the positive x-axis. We rotate clockwise 312 degrees. We know 3/4 of a rotation clockwise would be negative 270 degrees. We need to rotate another 42 degrees clockwise, which would be approximately here. And now we convert to radians. Degrees simplify out. The greatest common factor between negative 312 and 180 is 12. 180 divided by 12 is 15. Negative 312 divided by 12 is negative 26. Negative 312 degrees equals negative 26 pi divided by 15 radians. I hope you found this helpful.